So any unbalanced force, this is showing any graph showing acceleration. Because an object is being moved. So let's look at, say, a dt graph. So on a dt graph, what does acceleration look like? Looks like a J. Let's try VT graph. What's a VT graph look like? As time progresses, velocity will increase, so it's just a straight line. Let's assume we have constant acceleration. So if I have a constant acceleration, say I'm accelerating at the rate of 3 meters per second squared, what's my graph going to look like? Straight across. Very good. Now let's just briefly review what acceleration and deceleration is in terms of our vectors. So we did this before, but we're just going to look at it again. When a force is exerted in the same direction as the object is moving, the object speeds up. So which direction did my vectors both need to go? The same way. I guess I just told you the answer too, but that's, yeah. I guess I said something weird. Okay, so our V goes in the same way, but now we're talking about force of an object, so I'm going to write down F net. And this equals acceleration. This is speeding up. What's zero? Oh, sorry, that's just like a ball moving. We don't have to draw that if that's confusing. Sorry. It's just an object. You could draw a bunny there or something, whatever. Bunny's velocity is the same as its force, right? Bunny pushing, that's the force. So the bunny hopping, so it goes in that direction. Right? Okay. Are you guys still awake?
No.
You want me to keep hopping around the classroom?
Yeah.
So, let's say the bunny needs to stop. Its velocity is still going that direction, but it's going to stop. So it's going to tighten its muscles and its force will be going in the opposite direction. So this is slow down, or we call it deceleration. It's spelled like celery. Deceleration. Celery. It's like celery. Okay, let's do an actual example now. Let's get into this. So an object has a net force of 640 newtons acting on it. If the mass of the object is decreased by a factor of 9, you have it that it says acceleration, right? If the, Morgan, what does it say?
Acceleration.
Really?
Yeah.
Of the object is decreased by a factor of 9, and the mass of the object is increased by a factor of 2. What is the new net force acting on the object? We're just focusing on magnitude only for this particular question. Okay, well, what the heck do I do? So I'm going to write out, for these questions, I'm going to write out an original and modified to keep my information separate. So my F net of my original is 640 newtons. I don't know direction in this question, so I don't need to write direction down on there. My M, I kind of just assume for the purposes of this that it's like 1. and acceleration is like 1, and I change it by those factors. So I'm just going to write m and a, just going to leave those blank for now. Okay, so I know that F net is equal to m times a. And in this original situation, that is equal to 640 newtons. So that's what I know about my original situation. In my modified situation, F net is what I'm trying to find. Now my mass, and I'm also going to label this as F net prime, meaning like the second one. So if you when you put like a line on top of whatever you're dealing with, that's saying that's F net prime. We call that. That's like the second one. So m prime is equal to 2 times m because we increased by a factor of 2. This was our original m. M prime is 2 times our original. So a is equal to, or a prime, sorry, is equal to a divided by 9. So now I'm going to put all of this into my formula. So I know that my F net,
Is that a 9 on the bottom?
yes, it is. I can kind of, I'll rewrite that to, so this is A divided by 9. Does that look better?
Why is it 9?
Because I changed it, it said decrease by a factor of 9. That doesn't mean minus 9, it's actually decreased by that many, like that factor. So it's been divided by. Yeah, that was from our question. Very good. Okay, so F net prime is equal to m prime times by a prime. Now I'm going to substitute in this for m prime and this for a prime. So now I can write F net prime is equal to 2m times by a over n, or 9n. So I can substitute in so now I can simplify this and I divide out the 2 and the 9 here. So I'm going to go 2 over 9. I've divided them out of the equation. And I can go m times a.
How did you move the A?
It's on the top of the fraction. So it's like 2m times by a over 9.
Why isn't the 9 under it all then?
Because I factored it out, so we can go like this.
Can you do that step by step?
Okay. I'm feeling like you... Okay. So when I multiply them together, I have 2ma over 9. I'm not doing anything to the actual set equation. I'm just rearranging it to look a little differently. Or I don't have to. I can just do it simply, maybe. Maybe you guys would like it like this better. So if I multiply these two things together, I have 2MA over 9. This MA, I said was 640. So I'm going to put that into there.
So now you have 640 over 9.
Yes. So it's just taking in those factors and then substituting in what we knew. We knew that MA was equal to 640. So we substituted that in to our modified. This is kind of a hard question. So perhaps we should do an easy question together and that will help you.
You use your you count your factors as things.
No. So let's just fast forward here and let's do a practice problem together that you will find probably a little bit more straightforward. So go to the page where it says force practice problems and let's do number 1 just to kind of simplify life here a little bit. Okay. So, practice problem 1. So this is just straightforward. The net force acting on a 6 kilogram grocery cart, is 12 newtons left. Calculate the acceleration of the cart. So, what do we know? We know the mass is equal to 6.0 kilograms. We know that F net is equal to 12 newtons left. I'm trying to find A. I know that my F net is equal to M times A. I'm solving for A. Right now A is multiplied by M, so I'm going to divide by M, divide by M. So my formula is F net divided by M. So 12 newtons divided by 6.0 kilograms. A is equal to 2.0 meters per second squared left. Make sure you put in your direction. Okay, so a bit more of a simple example for you. Sorry, sometimes I don't realize how much things will blow up. Okay, let's go back and do the last example that we have.